Okay, so this is the first practice problem for induction. If you don't know what induction is, I'm not sure if I've uploaded the video on it, but it should be there, depending on what day it is. If it isn't, then you're just going to have to wait, or you can just check out any other YouTube video, because I'm obviously not the only one. Wish I was. But either way, so prove 2 to the n is less than n for all n is greater than or equal to 1. And if you think this is kind of intuitive that this would be true, well, that's your opinion, really. It's really a proof. So just really to exercise, I guess your rational part of your brain, I guess you'd say. Either way, I don't want to get too much into that. So go on and prove it. Okay, so I guess I'm going to assume that you're done with that 1 second I gave you, because I only paused the recorder. Anyways, I guess I'll get started. So what we have to do by induction, so we have to make a base step, which I usually, because we're gonna have the base step be n equal 1. What I really like to do, just because it's, I guess it's more of an abstract kind of thing I like to do, is I like to say this is S of n. Just say that's the hypothesis that we are trying to prove with the inductive step. So first, for the base step, I would say, okay, well, S of 1, I merely just put n equals 1 into this hypothesis thing. And what does S of n equal? Well, it equals 2n is greater than n. I should probably use different colors, just like Khan Academy, right? Nostalgia. Okay. So S of 1 equals 2 to the 1, which is greater than 1. Okay, so we obviously do not need to prove this. We know that 2 is greater than 1, so we know this is true. Other color. Purple. Yeah, that looks nice. So S of, let's go with S of n, which we already know what it is. 2 to the n, which is less than n. How induction works is by assuming that this is true, assuming what you're trying to prove. I know that kind of seems weird, but you're just gonna have to trust me on this, or just check out hopefully my next video, because I on it. So you're going to assume this to be true, and I'm going to get a new color, and we're going to try to prove S of n plus 1. Maybe I can go into this why you assume this part. Well, it's kind of just trying to show that this is true. You're trying to prove that, you're really just trying to prove that S of n implies S of n plus 1, and this is what you're generally just trying to prove. That because we assume this hypothesis, therefore it implies this. And if it turns out to be what you would expect, then you know it would be right. I don't want to go into too much in that. I just thought I would put that there. and feel free to correct me if I'm wrong. It's what I generally like to think of it as. So s of n plus 1, now we're just going to replace n plus 1 with n. So this is going to be equal to, oops, maybe a light blue. That might look cool. Oh. Can barely tell that it's blue. Okay, so 2n plus 1 is less than n plus 1. Okay, so this is what we're trying to prove. Or at least deduce from this. Okay, so well, it looks like if we take s of n, I know this because I've done this in my class before, so I know this problem, hopefully. So if I do 2n, no, it already seems I messed up. Sorry. So it looks like that if we take 2n and times it by 2, which would be 2n plus 1, same expression right over here, and then we were to times this over here, which is now 2 times n because we times it by 2. Basically, we just times both sides by 2 over here. And because this is 2n plus 1, this is 2n, which also God, I'm lost for words right now. I guess I'll put this right here. It's been a while before I've done this. Okay. What else can we do? Okay, well, looks like this can be greater than or equal to n plus 1. It's only equal to this expression. 2n is only equal to n plus 1 when n equals 1. So this is a sometimes expression. But other than that, it's greater than. So that means that it's never going to be greater than this expression. If it's never going to be greater than this expression, then we know that it's always going to be less than or equal to it. So we know that it's less than this expression. So what have we come to the conclusion of? 2n plus 1 is less than n plus 1. And then, along with my crappy handwriting, we will put, I believe this is how you do it. And I always get these confused, but I believe you're supposed to put a square or q dot EED and then by induction. But yeah, so I might have to look that up for the next videos. Anyways, I hope you enjoyed, and maybe this was a bit too long for something so simple. Hope